So given the function f of x equals x squared plus 6x plus 8, we have to draw that function out. So let's see what happens whenever x is equal to 0. So when x is equal to 0, that's where it's going to cross the y-axis. So when x is equal to 0, we'll put 0 in for this here. We'll get 0, 0, so y would have to be 8. So it's going to cross the y-axis at point 0, 8. So that's one of the points on the graph that we're interested in. Now we're also interested in finding the roots, and we know that we can find the roots by working out where it cuts the x-axis. So it cuts the x-axis here whenever the value over y, that is f of x, equals 0. So that is whenever x squared plus 6x plus 8 equals 0. But we can rewrite this x squared plus 6x plus 8 as x plus 2 times x plus 4. So you can multiply those out. You have x squared with the first term. We'll have 4x here plus 2x is plus 6x, and 2 times 4 is 8. So that will be equal to 0. So these are the factors of this equation here. So it means that the roots are going to be given by x equals minus 2 and x equals minus 4. So that means that the roots of this equation, the points where it crosses the x-axis, are going to be given by minus 2, 0 and minus 4, 0. So this has us got another point, 2 points that we're interested in for the graph. Now a thing also to note here is that the quadratic function here is symmetrical. So whenever this cuts the axis at minus 2 and minus 4, well, halfway between minus 2 and minus 4 is minus 3. So this here is the equation of the axis of symmetry. So the interesting thing about that is where the axis of symmetry is, that's where we're going to have the turning point. Now we'll draw this out just in the next page and it will become more apparent to you. So if the axis of symmetry is x equals minus 3, well, what value for y is that? So we put the minus 3 back into our original equation and we get f of minus 3, we work through that, we get a value of minus 1. So it means the turning point is at minus 3, minus 1. So we've got this point here where it cuts the y-axis, and we've got these 2 points here where it cuts the x-axis, and we have the turning point given by this point here. So let's go and draw this out just roughly on the next page, and then after that we'll put it into the graphical calculator and see whether that is actually the correct graph that we've drawn out. So these are the 4 points here. There's a point where it cuts the y-axis along 0 up 8, so that's this point here. We've got the 2 roots which are given by minus 2, 0, which is this point, and minus 4, 0. And we can see that the quadratic equations are symmetric. So it means that between this point and this point here, that's point minus 2, that's point minus 4. So this point here must be, in the middle, must be minus 3. And the turning point is going to be given by minus 3, minus 1. And it's a quadratic equation in which the squared term is positive, so we know it runs like this. So it means that this function is going to run just like that. So this is the function drawn out, just roughly. But you can see here that that's a point minus 2, 0, and that's a point minus 4, 0. So the function is symmetric. So it means that the function is going to be symmetric halfway between these 2 points. So halfway between these 2 points is the minus 3. So it's symmetric about those points. So let's go ahead now and we'll put the function into the graphical calculator and we'll see whether we get this. So our function is f of x equals x squared plus 6x plus 8. And you can see our function here, so let's check and see the points are correct. We've got the point at which it crosses the x-axis is minus 4, 0 and minus 2, 0, and we have the turning point which is minus 3, minus 1, and the point at which it cuts the y-axis is 0, 8. So that's exactly as we'd seen and we've worked out in the previous page. So thank you for listening. I'll get you in the next video. Goodbye.